Here we show gaseous H2O, also known as steam. As you can see, the particles are moving very quickly. They move around the entire container, and are usually quite sparse. There is also the occasional collision between two or more molecules. H2O, as gas, usually will exist from 100 degrees Celsius plus, but can exist from 0 degrees as the temperature is quite high. The particles have a lot of energy. This is why they move so quickly and freely. If we reduce the temperature of this container, we also reduce the amount of energy the particles have. Thus the attraction between the particles will have a greater effect. They slow down and do not travel as far. This is now showing H2O in its liquid form, also known as water. The particles will slide around each other. As it is now a liquid, the water will settle at the bottom of the container, and even if rotated will conform to the lowest possible point, as it is now denser and weighs more than the surrounding air. If we continue to reduce the temperature, the particles will slow down further. As they slow down, they will become more rigid in their structure, and will form a hexagonal bond. This is now showing H2O in its solid form, also known as ice. As there is now less energy, the attraction between molecules now has a greater effect on the structure. The volume of the H2O has increased from its liquid state, and there is now more space between the particles. You may also notice the hexagonal structure which has now formed. This is why snowflakes have their characteristic six-sided shape. This is how the particles will stay in this state. Rather than moving freely, the molecules are relatively locked into position. They will vibrate and collide, but rarely swap places. Now as ice, H2O will stay together and will keep its current shape, rather than conforming to the container. Thank you for watching our particle model demonstration.